All right, thank you. Name is Ali. Again, I am with Özyeğin University. This is the first two are master students, and then Zafer is back at the back again for the demo. And then Burak and Gwendal are from Cinemedia. So this is a joint project between Özyeğin University and Cinemedia. So let's start. Currently, we have a lot of, maybe not too many, but still quite a few watch party implementations out there. There are websites like FlickCall, Scener, and Scener.com, and so on. And the difference between the previous presentation and this one is there is also this party component in this watch party. So what I mean is that there is a real-time audio video between the participants, not just the main content you are watching. It could be live video, it could be on-demand video, but a bunch of us, our friends get together and then we are also having this conversation. Maybe we are playing just a basket, we are watching a basketball game and we are cheering at the same time and we are showing some reactions and so on. And every implementation out there today, they are using the HLS for the main content, for main delivery of the main program, and then WebRTC for the party components. So there's a real-time audio-video communication, and then there's the HLS HTTP-based content delivery behind the scenes. But you are really trying to combine two incompatible words into one platform, into your application. So what's happening here is that, we have the context pipe, dash HLS, whatever you use, and it's supposed to be high fidelity, hopefully no loss, no buffering, and so on, because that's the primary reason we are in that party. And then there's the excitement pipe, which is the party components like audio, video. Yes, you would like to have a perfect audio, video, and then more critically, it has to be really, really low latency, pretty much like real time. And but maybe fidelity is not going to be really that high, right? You are combining these two words, and then what you are getting is really implementation complexity and the overhead of synchronizing different components among different protocols and so on. So we would like to solve that problem with mock transport, obviously. So we have our relay implementation in Mocktail, right? There are other relay implementations as well. And this is going to be the only component that's going to take care of all these tasks for us, right? So one relay to rule all of them. So there's a consolidated infrastructure advantage. It's a single relay. I'm not going to run an SFU or another WebRTC component or another HTTP CDN. It's just a single relay. And then everything goes through a single quick connection. So once you are in the party, you have a single connection to the relay, and everything actually goes into that pipe. And that gives us a couple of advantages. First, within a single connection, I can prioritize my stuff accordingly, the way I like, and which is very powerful, actually. And then everything is under a single congestion control window so that I am still being network friendly, right? And then mock relay, our relay and any other mock relay is supposed to be payload agnostic, so it's not really looking into what's really being carried. It's just looking some, headers and some extension headers maybe to understand, how the priority is going to be, was set so that it acts accordingly. So we have in this paper, this is a short paper, but we have a full paper in submission. So what's happening is that we have this. Sorry, I need to go back, I think. Trying. Yep, here you go. So we have this dual pipe strategy. So it's still, oh, all right.
You have automatic transition?
No, I don't. Okay, this is weird. Okay, let's continue. Hopefully you are not pressing anything there. Okay, so, okay, this is weird. Okay, hopefully it will stay here. So, is something wrong with the clicker?
No, I think you got some kind of a transition. Yeah, it's in your presentation probably.
No, it's supposed to be, it's not automated, so it should move forward when I click. Okay. So we have this dual pipe architecture where, yes, it is still a single quick connection, right? But we have the excitement pipe, which is our party components, and then we have our context pipe, which is our main content, okay? So these are logical pipes within a single quick connection, and they are still sharing the congestion state. Okay, let's see. The previous slide, please. Can you just go out the window and show the PowerPoint directly? I don't care.
We're hitting it once, it's doing it by itself, we don't know why.
Can you just exit the presentation mode and show the slide so that I can continue the talk? I don't know what PowerPoint, I mean. Anyway, okay. Go back to previous slide. The previous slide. Yes, dual pipe strategy. So we have a single quick connection, and then there are these two logical pipes, and then obviously we have our control stream. The context pipe, it is one-way video, so it could be live video or it could be on-demand video, and then we are using reliable quick streams here because we don't want to have any packet loss or missing frames and so on, right? So there's retransmission involved, right? And then this pipe prioritizes completeness over latency. So we are trying to get the best quality, possible, and we can tolerate, maybe 1 second latency or 2 second latency is not that critical. But we have the spoiler prevention model, something we define, just like similar to the previous talk, like we are trying to keep everybody involved in the party, within a tolerable window so that, they are sharing the excitement, right? The excitement pipe, on the other hand, it is bidirectional, right? There is party video going out from you, and then party video coming from the other partiers, and then same thing for audio, right? In this case, this is critical, and this is, I think, one of the most important parts of this work. Audio is actually carried over the, quick datagrams. So, MoQ transport allows you to do both modes of quick. So we have quick datagrams here, meaning that there is no retransmission for audio. We are trying to achieve the minimal delay, and then the datagrams are not head of line blocked, so they just go, right? The audio packets are relatively small, so we are just pushing them as soon as they are available to go. The video, on the other hand, my real-time video and your real-time video is carried still over quick streams. Now, we can do maybe some retransmissions if time permits, but we have this early discard policy. If we think that something is not gonna make it by the deadline, the sender is gonna drop that, the rest of the objects within that MoQ group, which is essentially your GOP, and then you're gonna continue with the next GOP. And the relay is gonna do the same. So this is really to avoid any delay accumulation, because this excitement pipe is supposed to be real time. We cannot really allow too many retransmissions back to back or too much buffer bloating in your video pipe. So it's still stream-based, so theoretically there are retransmissions. We want in-order delivery because of progressive encoding in the video pipe. But if it's not gonna make it, we just cancel them, okay? Next slide, please. Okay, let's see whether this is gonna work. So the most powerful feature in MoQ transport, I think it is prioritization. So if there is no congestion, and if you are watching the main content without no problem, and I'm getting every friend's video and audio perfectly, things are fine. Doesn't matter what you use. You can use UDP, TCP, whatever, right? But if we are under stress, if there is some congestion, we need to make some decisions, because we are watching some live content or on-demand content, but we are trying to stay in sync. And at the same time, I'm trying to get some real-time video and audio from other participants, right? So we have our relay, and this could be the sender as well. I'm gonna explain in a few minutes. So there is all this stuff coming into the relay, right? The main content is coming from an original publisher, and then all these audio, video, party tracks coming from other participants. There are multiple flows, but I'm just showing only one audio and video over here. And then if, the control stream, by definition in the spec, it has the highest priority. So you gotta make sure that every MoQ message actually gets transmitted to the other side. It's the highest priority. In our implementation, main content is the second highest priority, so we make sure that the content is weaved perfectly. And then audio, party audio is the medium priority. So even if we are not gonna get party video, we wanna make sure that we get the party audio. Because audio, audio is fine, but video without audio is not really very useful. And the party video is the lowest priority here. It is still latency sensitive, as you can imagine, but it's cancelable. So we can actually cancel some of the mock objects in that stream. So if there is less bandwidth going out from the relay to your specific receiver, then what we are going to do is that we are going to obviously send control messages. We are going to keep forwarding the main content, but the party video is going to be removed, right? The relay is going to decide this is not going to make it, so it will just be removed. So alternatively, if there is really much less bandwidth, then we are gonna keep pushing the main content, but altogether the party content is going to be disabled. So you are not going to be kicked out of the party, but essentially you are not going to receive anything from anybody else. Obviously, this is showing one way, but the party tracks are going to move in the other direction as well. And then the bandwidth obviously can change in either direction, and then the relay is going to do the same. And then the same thing applies to the sender. When you are sending data, right, if there is not enough bandwidth, then you are going to drop your video. If there is not enough bandwidth for the audio, you are going to drop that too. So this is what our architecture works. So this is for a single room. There are a bunch of partiers. We have a room server again over WebSocket, and then everything coming from a main content publisher, and then the party tracks are published obviously by each individual, and then they are exchanged over the relay. So excitement pipe is bidirectional between the parties over relay, and the main content is one way over the relay from the original publisher. So all these video flows are prioritized. All these mock flows are prioritized accordingly, and then we implement it that way. So this is how we were like last night. We were trying to make this work. It was working, but I hope it will work now. And let's see whether this is still the case. So can we switch to the screen? There are a lot of things when you mix datagrams and streams in a single relay implementation, and when you want to put everything intact. So I'm going to actually try to get into the demo as well. So let's see. So this is the still live video coming from, this is in Chicago, so it's not too far away. The latency target is 750 milliseconds. So it leaves the Chicago encoder, FFmpeg encoder, and then it's displayed here in 750 milliseconds. So we have like, okay, let me hopefully turn on my camera and then it will work. Okay, so Zafar is at back. There are a couple of other computers there. And you can disable, if you don't want to see a specific person, you can disable their video over here, or disable their audio as well. So this is really like unsubscribe from that particular track, right? And the webcam videos are 360 and 300 kilobit per second, so relatively low quality and low resolution. And the main content here is 720p, lowest HD, 2 megabits per second. But again, mock has nothing to do with the video quality or the bit rates and so on. It is really agnostic to this, right? So I can probably show this way. And then you can see how well we are synchronized. The leader can change the target latency if everybody complains, hey, look, our live video is stalling too often and so on. The leader can say, okay, we are going to fall back like by 3 seconds, so we are going to be 3 seconds behind the live point. So everybody is going to be hopefully more comfortable with the live video. And unfortunately, we can't really introduce some congestion here. But again, if congestion starts happening, first of all, the video is going to drop, and then the audio is going to drop. But hopefully, the video content is going to continue. The chat track, I don't know how we prioritize that one, but it's rather small, so I think it's maybe medium priority. That's it, wrap. I don't know why my timer is no longer working. So while we are at the demo, I can take questions. I don't think I have any more slides anyway. We have some results, but the demo is probably more interesting.
It's
Any
amazing.
questions?
It's amazing that you're able to do these live demos, Ali.
Yeah.
It's really good. There is room for a question. There is a question in the room. No?
Yes, Alex.
There is.
Imagine we had a new pandemic. During the pandemic, we had a lot of live streaming synchronization for musicians that wanted to
Yeah.
Oh man.
how low can you get it?
So the
That's a good-
question is on how can you use this for making music jointly, remotely, a music watch party.
I am not a musician, but I know that those guys are quite sensitive to latency difference. So, I mean, frankly, we haven't really tested that yet. But I mean, it has a lot to do with your network conditions, your Wi-Fi, and everything, right? I mean, even if like 10 milliseconds or 50 milliseconds latency is gonna disturb them, those musicians, I mean, I don't know. I mean, it's not really a mock issue, but really, I mean, in mock, I mean, one thing you need to understand, everything goes through a relay. And how close these musicians to that relay or to their individual relays, like the nearest relay, but how close they are in terms of geography, I think that will be more deterministic in terms, for the quality rather than the actual transport.
It's mostly a question about audio end-to-end, right? But I have to stop it here, unfortunately.
Really? Let's take one more question.
No, there is no time. There is no time. I'm sorry.
Well, I'll be here. I'll be
You'll
around
be here for
in
questions.
case you want to see the demos.
Yeah.
We don't have the source code posted for this yet because this is just coming out of the oven, but it will be posted soon. Thank you.
Thank you very much, Ali. Great to have a demo.